Welcome everybody to the video presentation of PLDC assignment presented by 30th students of SLIIT. The topic we are going to discuss in this presentation is Object-Oriented Programming Concepts of Java. Java is a popular and powerful language. Although comparatively simple in its language structure, there are a number of subtleties that can trip up less experienced programmers. It's based on C, and of course Java is object-oriented. So in this presentation we'll be discussing the following concepts: classes, objects, instance, encapsulation, abstraction, inheritance, and polymorphism. First, let's look at classes. A class is a blueprint from which individual objects are created. Here it shows a simple class. A class can contain any of the following variable types. First is local variables. These are the variables defined inside methods, constructors, or blocks. The variable will be declared and initialized within the method and is destroyed when the method has completed. Second type is instance variables. These are the variables within a class but outside any method. They are instantiated when the class is loaded. Instance variables can be accessed from inside any method, constructor, or blocks of that particular class. The third type is class variables. These variables are declared within a class outside any method with the static keyword. Now let's look at some important topics that need to be discussed when looking into classes of Java language. When discussing about classes, one of the most important subtopic would be constructors. Every class has a constructor. If we do not explicitly write a constructor for a class, the Java compiler builds a default no-argument constructor for that class. Each time a new object is created, at least one constructor of that class will be invoked. The main rule of constructors is that they should have the same name as the class. A class can have more than one constructor. Look at this code example. Here for the puppy class there are two public constructors. One is the default no-argument constructor and the other is a constructor which takes a string value as its argument. Java also supports singleton classes where you would be able to create only one instance of a class. As mentioned previously, a class provides the blueprint for objects. So basically, an object is created from a class. In Java, the new keyword is used to create new objects. In this example, it creates a new puppy object called myPuppy. There are three steps when creating an object from a class. First is declaration. A variable declaration with a variable name with an object type. Second is instantiation. The new keyword is used to create the object. Finally, the initialization step. The new keyword is followed by a call to a constructor. This call initializes the new object. All the objects have a state and behavior. A software object state is stored in fields and behavior is shown via methods. So in software development, methods operate on the internal state of an object, and the object-to-object communication is done via methods. The next concept we are going to discuss is encapsulation. Encapsulation is one of the fundamental OOP concepts. It is the technique of making the fields in a class private and providing access to the fields via public methods. If a field is declared private, it cannot be accessed by anyone outside the class, thereby hiding the fields within the class. For this reason, encapsulation is also referred to as data hiding. Encapsulation can be described as a protective barrier that prevents the code and data being randomly accessed by other code defined outside the class. Access to the data and code is tightly controlled by an interface. The main benefit of encapsulation is the ability to modify our implemented code without breaking the code of others who use our code. With this feature, encapsulation gives maintainability, flexibility, and extensibility to our code. If we need maintainability, flexibility, and extensibility, our design must include encapsulation. So to do that, we should keep instance variables protected by making the access modifier private. Make public accessor methods and force calling code to use those methods rather than directly accessing the instance variables. We call the access methods getter and setter, which is also known as accessors and mutators. Look at the following code. In the box class, there is a private variable called size. So to use this variable, we need public getters and setters. Therefore, they have provided two methods called getSize and setSize. The getSize method will return the value of the size variable, which is an integer, and setSize method will allow you to modify the size variable. Remember, though encapsulation increases the maintainability, it decreases the efficiency. The benefits of encapsulation is listed down in this slide. The next concept we are going to discuss is inheritance. Inheritance is everywhere in Java. It's safe to say that it's almost impossible to write even the tiniest Java program without using inheritance. Inheritance is the capability of a class to use the properties and methods of another class while adding its own functionality. The generic class is known as the parent or superclass, and the specific classes are known as children or subclasses. It's also important to understand that the most common reasons to use inheritance are to promote code reuse and to use polymorphism. When we talk about inheritance, the most commonly used keywords would be extends and implements. These words would determine whether one object is a type of another. By using these keywords, we can make one object acquire the properties of another object.